I explained the rationale of why we run multiple regression models to check the assumptions of mediation analysis. If you have not watched the previous videos, I strongly recommend that you pause it here. You check the video about the basic concepts of mediation, and then check the video on SPSS, and then come to resume your this tutorial, because it would make much better sense for you why I'm doing this step to check the assumptions of mediation analysis in JASP. So as I explained in the other tutorial video, you on the SPSS, you need to run 3 regression models to check the assumptions for the 3 part of your mediation model. That is 3 direct effect that is in your mediation model. However, if you have more DVs, that means that you need to do more mediation models. So I mean, for each mediation model, I'm saying that for each mediation model that you have in your analysis, you need to do 3 steps of check 3 regression models to check the assumptions for each step separately. And if you have multiple mediation models, you should do the process again from scratch for each mediation model. Imagine that I may have just one mediation model here. That means I just have one DV, one mediation, and one IV. So let's start. What is as I explained in the other tutorial, the first step in a mediation model is the direct path, the direct effects of IV on my mediator. And again, this is one of the confusing aspects of JASP that I would recommend spaces over JASP usually. JASP here is using the term covariates, and it means actually IV. It actually means predictor. So, but however, JASP does not differentiate between an IV and a covariate. So ask you to put all of your variables, IV and covariates, in one column, and it called that as a covariate. So that's why it's confusing, but it does not mean that necessarily covariate. So you can put your IV here. So this is a confusing terminology of JASP only. In SPSS, for example, you have a separate boxes, for example, if you want to include other factors. But here, yes, the IV and covariate both coming in one box that is called covariate. So as you can see, but I named my variables in a way that can be clear. That's here, I check my IV. So the first part of my mediator is that my IV predicting my DV, a dependent variable. So, and I am not interested in any of these results because I just want to do assumption checks. So to make it neater, I would suggest just remove these estimates and to just that and remove even model fit or any of these statistics because you just want to check assumptions for this. And then when you set it once, it will be there for all of your steps and you can quickly check the assumptions for all of the steps. So let's take care of the settings, and then we check the assumptions for each step. What I need to check, as I explained with more details in the other video, the first one is tolerance and VIF for the assumption of multicollinearity. Oh, actually, sorry, so JASP doesn't, you should actually do estimate. So it's also another aspect of SPSS that SPSS allows you to do assumption checks without estimates, but I had forgotten that JASP actually does not allow you. So you should probably keep this activated, the estimate. And so tolerate the VIF for multicollinearity assumption. You need also Durbin-Watson for independence assumptions. You can do Kerr-Weiss diagnosis for outliers, and also it will automatically include coexistence as well. Let's see what else we can check here, and plus also. That plus you need to residual plus sub-residual versus predicted that it will check linearity and homoscedasticity together. And you will have QQ plus substandardized residuals that actually can check the normality of residuals for you. And yeah, so I'm just double checking I didn't miss anything. No, that should be all now for also coexistence or synchronous. So now let's just start to see for my first step of my mediator that my IV actually include predicting my mediator. What is the assumption? The first thing I want to check is the VIF. So if the first thing Durbin-Watson, so I missed that at the top. Durbin-Watson, that is the assumption for independence. As long as your Durbin-Watson statistic for M1, because you see model 1 IV is included for you check M1, that is highlighted by default by JASP. So as long as it is close to 2, that means that this assumption is met. And I explained in the other videos that what does it mean or what would be the level. So I won't repeat it here. And the group supervision also we will address that more. So this next assumption is VIF for IV. that as long as it's less than 10, that means that the assumption is met. That means that there is no multicollinearity. So the assumption of lack of multicollinearity is met, the assumption of independence is met. Now I'm going to see the influential outliers. So you see, even though I didn't teach Cook's distance, it's still included that here. So that means that JASP has suggested that these participants, that participants number 30, number 92, number 130, number 141, they are potentially outliers. However, the Cook's distance for them is less than 1. That means that although they are outliers, they are not influential outliers. If the Cook's distance for a participant is less than 1, that means that it's unacceptable. Or that means that even though they are outliers, they are not significantly affecting your result. And if you want to check Cook's distance more clearly, that you see the threshold for Cook's distance is 1. That you see that no variable, no participant is included here when I click on coexistence. That means that there is no influential outlier in my data. And if I like, I can keep my participants, all of my participants in my data. It doesn't affect my regression model and hypothesis testing. However, if my other assumptions are not working well, or if I have some non-significant result, I may come back and remove these participants and see if it can help my mediation model to give me better results, or my assumption checks giving me better results. But it's not very likely because the coexistence is okay for them. So that means that they are not influential outliers. So also don't forget to double check this so that you can specifically also get the coexistence here, that if you don't expect any participants come. See, if a participant come here, that means that you probably may need to remove that participant from your data. But still, you should remove and see if it changes the data or result. If it doesn't change, you may want to keep that participants even. So, and the next assumption is the scatter plot of residuals versus predicted, that I explained how it's interpreted in the SPSS tutorial. But again, in summary, so in SPSS, I said that you can still align that, but the advantage of JASP that it actually draw a line for you. So as long as the data is evenly distributed across the line, and also they are sort of fragmented, they are not focused on very specific corner of your plot, that means that both the assumption of linearity and homoscedasticity are met. That are two basic assumptions of regression analysis that I will explain. I explain a bit more about these assumptions in the other tutorial and how you need to refer to them in your reports. And the assumption of residuals of normality of residuals. You remember, normality of raw data is not our constant for mediation analysis, but normality of residuals is important, and it is our constant. So here I can see there are a slight violation of normality of residuals, because we expect actually that all of these data points are around the line. However, it's not very strong violation. For example, if you ask me, I would say that go ahead and do your mediation analysis with that. So however, if you want to be very strict perfectionist, you may want to like remove these outliers and see if it can help these, and then you can go to some other measures, like for example, to go transformation. But for me, I would be consider that acceptable. It's not a strong violation from normality of residuals. And also your mediation analysis for the mediation effect is based on bootstrap estimation. That bootstrap is robust to normality of residual assumptions. So that means that your mediation effect is not going to be affected by this, even if it's strongly violated. So, but it's not even a strong violation here. So that's it for the first step, but I keep it in mind that maybe it's not perfectly, it's almost met. I can say it's an acceptable level for step 1. And now that all the settings are the same, I don't change it. I'm just going to check this next steps of my regression, my mediation model. So as I said, the first step is that my IV predicted my mediator. And the second step is that my mediator actually will control my DV, like with controlling the effect of IV. That means that the main predictor is path B actually in your model. That means that the main predictor is actually mediator that predicting DV. However, I need to control for the effect of IV because it's to get purely the effects of mediator on my DV. So for this way, I show in a little bit different in the way that we do it in SPSS and JASP. In JASP, you should put all of the mediator and IV here as covariates, but here you change it. You say that I want to control IV. I don't want it to consider as the main predictor. And you see that is now sort of uh, not highlighted and sort of with a pale like color here. So that means that it's controlled. IV is controlled, and I'm just focusing on the effects of mediator. The assumption that I'm going to check is Dubin-Watson, that you see the statistics, this mediator is true, around 2, that is acceptable. The assumption of independence is met. Then VIF, that I see that for my mediator that actually is important is actually met, that is less than 10, so it's met. I see that there is no outlier here, and when I check for coexistence, no coexistence or outlier here, so that's met, this assumption. So, and also I see that the scatter plots show that the assumption of linearity and homoscedasticity is met because the data points are evenly distributed. And here is very good. This is a perfect, very good actually a situation for the assumption of normative residuals that is met actually is mostly around the line. So everything is okay for my second steps of mediation analysis. The last step of my mediation analysis, that is when my IV predicting my DV and with controlling the effects for mediator, that is path C prime actually. And here, this is similar to the last one, but here we control mediator and the IV is the main predictor. It's the last step of your mediator. And the statistics should be the same. It shouldn't change that. And but just in case, just to be very standard, I make it exactly like the steps of the mediation analysis that you see doing Watson is okay, you see VIF is okay, like for IV, and you see that the scatter plots for homoscedasticity, linearity is okay, and normality of residuals also is okay. So that's complete. That's all I needed. If I had another mediation model, then I would come and define that, follow these 3 steps again for that one. But that's all for you need to check the assumptions for mediation analysis.